the dust kicked up by the California desert wind as Agent Kenji Nakamura adjusted his telephoto lens, focusing on what appeared to be an impossible sight stretching across the Mojave landscape. Row upon row of pristine military aircraft sat in perfect formation, each one wrapped in protective covering, extending beyond the horizon in numbers that defied comprehension. It was September 1945, just weeks after Japan's surrender, and Nakamura was documenting evidence that would shatter every assumption Tokyo had held about American industrial capacity. Nakamura had been one of Japan's most effective intelligence operatives in America since 1942, operating under deep cover as a photographer for agricultural publications. His real mission was documenting American war production capabilities for the Imperial General Staff. But nothing in his 3 years of espionage had prepared him for the mathematical impossibility of what lay before his camera. The storage facility near Victorville contained over 15,000 aircraft, more planes than the entire Japanese Air Force had possessed at its peak. And according to his carefully cultivated sources in the aviation industry, this was just one of dozens of such facilities across the American Southwest. Conservative estimates suggested the United States had produced so many military aircraft that over 300,000 sat unused in storage yards, treated as surplus inventory rather than precious strategic assets. Japan had sacrificed everything to produce 76,000 military aircraft during the entire war, stripping the economy bare and sending children to work in factories. Yet America had built 4 times that number while maintaining civilian prosperity that exceeded Japanese peacetime standards. The mathematical reality was overwhelming. Japan hadn't just lost a war. They had been defeated by industrial arithmetic that made resistance futile. From the moment America entered the conflict, Kenji Nakamura had been photographing American agricultural developments for Sunset magazine since 1942, a perfect cover that allowed him to travel freely across the western United States while conducting intelligence operations for the Imperial Japanese Navy. His real expertise lay in industrial assessment, having graduated from Tokyo Imperial University with degrees in engineering and economics that qualified him to evaluate enemy production capabilities. The transformation of American industry since Pearl Harbor had been the primary focus of Nakamura's intelligence gathering, as Tokyo desperately needed accurate assessments of enemy manufacturing capacity to plan realistic military strategies. What he discovered consistently exceeded Japanese estimates by factors that his handlers initially dismissed as obvious American disinformation rather than authentic intelligence about impossible industrial achievements. His first encounter with American aircraft storage occurred by accident in March 1945, when a wrong turn near Davis, California, led him to a restricted area containing thousands of military aircraft arranged in systematic rows that stretched beyond visual limits. The casual security suggested American confidence in abundance rather than fear of enemy action, treating massive air fleets as routine inventory rather than strategic vulnerability. The photographic equipment concealed within his agricultural camera gear captured evidence that would later prove crucial for post-war Japanese understanding of American capabilities. Each image documented not just individual aircraft, but systematic organization that treated tens of thousands of planes as manageable inventory through standardized procedures and administrative efficiency that Japanese military bureaucracy had never achieved. Quality assessment of stored aircraft revealed American manufacturing standards that exceeded Japanese specifications, despite mass production methods, the Japanese tradition associated with compromised craftsmanship. Protective coverings, systematic maintenance schedules, and climate control procedures maintained aircraft in operational condition despite indefinite storage periods that would have been unthinkable for resource-constrained Japanese planning. The economic implications gradually became apparent through conversations with American workers whose casual discussions about aircraft disposal, scrapping procedures, and surplus sales suggested industrial abundance so complete that military equipment was treated as commercial commodity rather than precious strategic asset. Americans were planning to sell military aircraft as civilian transportation after converting production lines back to peacetime manufacturing. Transportation logistics for moving stored aircraft revealed infrastructure capabilities that Japanese forces had never developed. Railroad networks could deliver aircraft anywhere in the continental United States within days, while specialized handling equipment enabled rapid activation of stored units without compromising technical specifications. American abundance included systematic procedures for surplus management that Japanese scarcity planning had never contemplated. International implications became clear through intelligence about Allied aircraft sharing programs that provided American planes to British, Soviet, and other forces from existing stockpiles rather than current production. Democratic abundance was supporting global alliances through surplus capacity that exceeded total Axis aircraft production across all nations and all aircraft types combined. The workforce diversity at storage facilities included specialists whose sole responsibility was maintaining equipment that might never be used operationally. Engineers, technicians, and administrators were employed full-time to preserve aircraft that represented more military aviation capacity than most nations had ever possessed. American economic capacity enabled systematic preservation of strategic assets through dedicated human resources. Personal transformation began as Nakamura realized his intelligence reports were documenting not just American military superiority, but industrial civilization that had achieved abundance beyond Japanese imagination. The mathematical impossibility was becoming undeniable through accumulated evidence that challenged every assumption about resource limitations and production constraints. The statistical reality of American aircraft production became clear to Nakamura through systematic documentation of multiple storage facilities across Arizona, California, and Nevada that collectively contained evidence of industrial capacity beyond Japanese comprehension. Conservative counting methods indicated over 50,000 aircraft in desert storage, representing more military aviation assets than Japan had produced during 4 years of total war mobilization. Technical analysis of aircraft types revealed production diversity that Japanese industry had never attempted. Fighters, bombers, transports, trainers, and specialized aircraft were represented in quantities that individually exceeded Japanese total production in specific categories. American factories had simultaneously developed and manufactured aircraft varieties that Japanese planners would have considered mutually exclusive due to resource limitations and engineering complexity. The preservation procedures observed at storage facilities demonstrated American confidence in continued technological leadership that extended far beyond immediate military requirements. Environmental controls, systematic maintenance schedules, and parts replacement programs maintained aircraft in operational condition, despite storage periods that would have resulted in complete deterioration under Japanese climate and resource constraints. Manufacturing quality evident in stored aircraft reflected systematic production methods that achieved reliability standards Japanese tradition associated only with individual craftsmanship. Mass production techniques had produced aircraft that met or exceeded hand-built specifications while achieving quantities that traditional methods could never accomplish, regardless of available resources or workforce dedication. Economic calculations revealed American aircraft production costs that achieved superior performance through industrial efficiency rather than resource abundance alone. Unit prices for mass-produced military aircraft compared favorably with Japanese costs, despite superior specifications, indicating systematic advantages in manufacturing technology and workforce productivity that competitive markets had encouraged. The workforce development that enabled such production included training programs for diverse populations that contradicted Japanese assumptions about technical competence and social organization. Women, minorities, and immigrant workers had contributed to aircraft manufacturing through systematic education and democratic participation that enhanced rather than compromised technical achievement. Innovation acceleration continued throughout mass production rather than being sacrificed for quantity targets, contradicting Japanese beliefs about the incompatibility of creativity and systematic manufacturing. Engineering improvements, enhanced materials, and design modifications had increased performance while reducing production complexity through competitive methods that authoritarian control had never achieved. Supply chain coordination supporting aircraft production operated across continental distances without the transportation disruptions that plagued Japanese manufacturing. Raw materials, components, and finished products moved efficiently between facilities using railroad and trucking networks that maintained delivery schedules regardless of weather conditions or competing military demands. Quality control procedures exceeded Japanese military specifications while processing millions of components through statistical sampling methods that ensured consistent performance across thousands of aircraft. American standardization achieved reliability through systematic testing rather than individual inspection, enabling mass production without compromising functional requirements. Strategic planning revealed American preparation for post-war aviation markets that assumed continued technological dominance through industrial capabilities developed for military requirements. Civilian aircraft development, commercial aviation expansion, and international sales programs would extend American aerospace leadership beyond military victory to peacetime economic competition. International cooperation through aircraft sharing had demonstrated American ability to support Allied air forces while maintaining production superiority that ensured continued advantages. Democratic values created sustainable partnerships that authoritarian systems couldn't replicate through coercive methods or ideological motivation alone. The accumulated evidence painted an undeniable picture of American industrial supremacy that had rendered Japanese resistance mathematically impossible rather than merely difficult to sustain through military courage or tactical innovation. The Kingman Army Airfield Storage Facility in Arizona stretched across desert terrain that seemed to extend forever, containing aircraft in quantities that challenged the mathematical limits of Nakamura's intelligence training. Systematic organization of over 35,000 military aircraft created geometric patterns visible from miles away, each row representing more aviation capacity than most nations had ever possessed in their entire military histories. Aircraft identification revealed American production achievements that defied Japanese understanding of industrial possibility. B-17 Flying Fortresses, B-24 Liberators, B-25 Mitchells, and dozens of other types were stored in quantities that individually exceeded total Japanese bomber production. Fighter aircraft included P-51 Mustangs, P-47 Thunderbolts, and P-38 Lightnings in numbers that surpassed combined Axis fighter manufacturing across all participating nations. The systematic preservation methods employed at storage facilities indicated American planning that anticipated decades of potential aircraft storage rather than temporary surplus management. Climate-controlled environments, rotating maintenance schedules, and parts replacement programs maintained operational readiness for equipment that might never be activated, treating massive air fleets as strategic insurance rather than industrial waste. Personnel management for storage operations employed thousands of specialists whose expertise in aircraft preservation exceeded Japanese technical capabilities for operational maintenance. Engineers, technicians, and support staff represented employment levels that surpassed Japanese aircraft manufacturing workforce, while managing equipment that represented more military value than Japanese total war production investment. Transportation infrastructure supporting storage facilities revealed logistical capabilities that enabled rapid aircraft movement anywhere in the continental United States within 48 hours. Specialized railroad equipment, mobile cranes, and handling procedures could activate stored aircraft faster than Japanese forces could deploy operational units, demonstrating systematic advantages that extended beyond production capacity to operational flexibility. Economic efficiency of maintaining vast aircraft reserves challenged Japanese understanding of resource allocation in strategic planning. Storage costs were absorbed without apparent strain on American fiscal capacity, while preservation procedures maintained equipment value through systematic methods that Japanese accounting would have considered prohibitively expensive for non-operational assets. Quality standards for stored aircraft exceeded Japanese operational requirements for frontline equipment through systematic inspection procedures that ensured consistent specifications across thousands of units. American abundance enabled perfectionism that scarcity-based planning had never contemplated, treating surplus military equipment as strategic assets worthy of commercial-grade preservation. Innovation continued improving storage techniques through engineering research that developed better preservation methods, enhanced environmental controls, and systematic procedures that maintained aircraft readiness despite extended non-operational periods. Competitive American industry encouraged efficiency improvements in areas that Japanese tradition would have considered routine maintenance rather than technological development opportunities. International implications of American aircraft storage became apparent through intelligence about Allied requests for equipment that could be satisfied immediately from existing stockpiles rather than requiring new production. British, Soviet, and other forces could receive American aircraft from reserves that exceeded their combined national production capabilities throughout the entire war period. The psychological impact on Japanese intelligence services reflected growing comprehension that American industrial capacity represented systematic advantages in resource management, technological development, and economic organization that authoritarian systems couldn't replicate through ideological motivation or administrative control methods. Strategic reserves documented through storage facilities indicated American confidence in continued global responsibilities that extended beyond military victory to peacetime international leadership through industrial capabilities that would define post-war aviation markets and technological competition for decades following the conflict's conclusion. The mathematics were overwhelming and undeniable. American aircraft storage alone exceeded total Japanese war production by factors that rendered resistance meaningless rather than merely difficult. December 1945. Nakamura's comprehensive intelligence report reached the remnants of Japanese military leadership through diplomatic channels, carrying photographic evidence and statistical documentation that would shatter every remaining illusion about the mathematical possibility of Japanese victory in any hypothetical continuation of the Pacific War. The numbers were so overwhelming that military analysts initially questioned the agent's competence rather than accepting the devastating implications. The documented evidence was irrefutable despite its shocking implications. Systematic photography showed aircraft storage facilities containing more military aviation capacity than Japan had produced during 4 years of total industrial mobilization, while production statistics revealed monthly American output that had exceeded Japanese annual capabilities, even at peak wartime manufacturing levels. Technical analysis conducted by surviving Japanese aviation engineers confirmed that American mass production had achieved quality standards that exceeded Japanese peacetime manufacturing, while producing quantities that traditional methods could never accomplish, regardless of available resources or workforce dedication. Democratic industrial organization had proven superior to authoritarian economic planning through systematic competitive advantages. Strategic implications extended far beyond military defeat to encompass fundamental questions about Japanese industrial philosophy and national economic development. American abundance had been achieved through technological innovation, workforce education, and systematic organization that Japanese tradition had never attempted despite centuries of craftsmanship, excellence, and administrative efficiency. The psychological transformation among Japanese military analysts reflected comprehensive reassessment of American capabilities that extended beyond industrial production to encompass social organization, economic systems, and cultural values that had enabled systematic advantages through democratic participation rather than hierarchical control methods. Economic analysis revealed American financial capacity that had supported global military operations while maintaining civilian living standards that exceeded Japanese peacetime prosperity through systematic resource allocation that benefited both military effectiveness and domestic welfare simultaneously. Democratic capitalism had demonstrated superior efficiency compared to command economy organization. Personnel development programs that enabled American success included training systems, educational opportunities, and social mobility that created human capital advantages through individual empowerment rather than collective sacrifice. American society had proven more effective than Japanese tradition for developing technical competence and innovative capability across diverse populations. Innovation acceleration under mass production conditions had contradicted Japanese assumptions about the relationship between quantity and quality in advanced manufacturing. American engineers had achieved continuous improvement in aircraft design, production efficiency, and operational capability through competitive methods that central planning had never accomplished. International cooperation through aircraft sharing programs had demonstrated American ability to support global alliances while maintaining technological superiority that ensured continued leadership. Democratic values had created sustainable partnerships that authoritarian systems couldn't replicate through coercive methods or ideological motivation alone. The workforce diversity that contributed to American success challenged Japanese assumptions about social organization and technical capability. Women, minorities, and immigrant workers had enhanced rather than compromised manufacturing effectiveness through systematic inclusion that democratic society had enabled despite traditional prejudices that other systems had institutionalized. Quality control achievements through statistical methods had exceeded individual craftsmanship standards while enabling mass production that Japanese tradition considered impossible without compromising functional requirements. American standardization had solved fundamental manufacturing problems through systematic approaches that individual expertise had never addressed. The final assessment was mathematically undeniable. American aircraft storage facilities alone contained more military aviation capacity than Japan could have produced through decades of maximum industrial effort, rendering any hypothetical military resistance futile rather than merely difficult to sustain through traditional methods. August 1946. 1 year after surrender, former intelligence operative Kenji Nakamura sat in the ruins of Tokyo, compiling final assessments of American industrial capacity that had rendered Japanese resistance mathematically impossible rather than merely strategically challenging. The ultimate statistics were staggering. American aircraft production had reached 324,750 military aircraft during the war, with over 100,000 units held in storage yards as surplus inventory rather than desperately needed military assets. The mathematical comparison devastated any remaining Japanese illusions about industrial competitiveness. Peak Japanese aircraft production had achieved 28,180 units in 1944 under maximum wartime mobilization, while American monthly output during the same period exceeded 9,000 aircraft, while simultaneously supporting global lend-lease programs and maintaining civilian aviation development that Japanese industry had abandoned entirely for military requirements. Storage facility documentation revealed American confidence in sustained technological leadership that extended decades beyond military victory through industrial capabilities that would define global aviation markets. Systematic preservation of surplus aircraft demonstrated abundance that enabled long-term strategic planning rather than desperate resource conservation that had characterized Japanese wartime economics. Technical superiority of American aircraft reflected research and development programs that had operated without resource constraints limiting Japanese innovation. Advanced electronics, sophisticated engines, and precision manufacturing indicated systematic advantages in industrial science that competitive markets had encouraged through democratic organization rather than authoritarian control. Economic efficiency of American production challenged Japanese understanding of resource allocation in competitive technological development. Democratic capitalism had achieved superior cost performance while maintaining higher wages and better working conditions than Japanese facilities through systematic optimization that market competition had encouraged rather than administrative direction. The workforce development that enabled American success provided lessons for Japanese reconstruction that would influence industrial recovery and democratic transition. Training programs, educational opportunities, and social mobility had created human capital advantages through individual empowerment that would define technological competition for generations following military defeat. Innovation continuation beyond military requirements included civilian aircraft development that applied wartime technological advances to commercial aviation markets. American aeronautical engineering had created systematic advantages that would dominate global transportation for decades through competitive methods that Japanese planning had never attempted. International cooperation through aircraft sharing had demonstrated American ability to support global alliances while maintaining industrial superiority that ensured continued leadership. Democratic values had created sustainable partnerships based on mutual benefit rather than coercive relationships that authoritarian systems had imposed through military dominance. Personal transformation among Japanese intelligence services reflected comprehensive reassessment of democratic versus authoritarian approaches to industrial development and technological innovation. American abundance had resulted from systematic advantages in social organization, economic systems, and cultural values that encouraged individual contribution to collective prosperity. The preservation methods employed at storage facilities indicated American preparation for post-war responsibilities that assumed continued global leadership through industrial capacity rather than military occupation. Strategic planning that maintained surplus aircraft demonstrated confidence in technological advantages that would influence international relationships through competitive excellence. Post-war analysis would reveal that American aircraft storage represented strategic insurance against future conflicts that never materialized, enabling peaceful conversion to civilian aviation without economic disruption. Democratic abundance had created capabilities that exceeded immediate requirements while establishing foundation for sustained prosperity. If this incredible story of how American industrial mathematics overwhelmed even the most sophisticated enemy intelligence operations inspired you, make sure to subscribe to our channel for more amazing tales of how democratic abundance rewrote the equations of global power. The Spy Who Counted Impossibilities had documented systematic American advantages that transformed warfare from tactical art to industrial arithmetic, where victory belonged to societies that could produce abundance rather than manage scarcity.